So from the beginning, today we're going to talking about reverse engineering with Solid Edge. First we're going to cover part one is an intro for reverse engineering workflow. And in this section, we're going to talking about what reverse engineering is, a general idea, and how it can be done with the scan data, okay? All right, so you guys already see this, but let's think about this again is what is reverse engineering? I guess most of the guys has something in your mind because based on the research, based on the survey that we did before, seems like the most of Einscan user, the scan data, the use of scan data will be doing reverse engineering. Like I would say around like 30% of people use the scan data to do the reverse engineering. So most of you guys already know what it does, but some of you may still don't have an idea of what reverse engineering is, okay? And here's a simple answer. This is my answer of what reverse engineering is I see reverse engineering as a design process, but you do it with the real object as a reference. So basically, when you're doing reverse engineering, you were still doing the design process. However, you are not start from zero. You actually have something that's actually, for our case, the scan data as a reference. And let's take a look of this workflow. Here I'm showing the full workflow, and you know, for anything in the real world. So usually, if you have something like a mouse or a cell phone in your hand, it always started from an idea, right? Something in your mind. And what the engineering do is they do forward design, okay, to make a CAD file of the object. Then they do manufacturing to machine out the real object or any other way to construct the real object. Or sometimes they may skip this CAD file part. This is actually the designing part, right? So sometimes it can be skipped so you can directly build your own things out of mind without any draft. However, you can see that there are some difference between this manufacturing step. So the real object, it actually has variance on the surface. It has some arrows inside, while the design is more ideal. Like for example, in your CAD file, a surface is pure flat. There's no variations on the surface. But if you machine out a surface, there will be roughness, right? So this is the arrow you have during the manufacturing. Then comes the reverse engineering part. You see here on the screen, we have this blue box, which means the inside is the reverse engineering process, okay? So it's all start with scanning. Or in our case, of course, if you're in other case, it might be like measuring with caliper or other tools. So after scanning, what you get is a mesh file, all right? And now you see that there's more difference between, there's some more difference between the mesh file and the CAD file. Comparing the real object and the mesh file, you see that the arrow is enlarged, it's amplified during the scanning process. Because the scanner itself has arrows, it's not 100% replicate the real object, right? And the surface might not be parallel anymore. And after we have this mesh file, next step, what we gotta do is we match features to get the initial model. This can be done in some of the software like Geomagic Essential, which we also cooperate with, or like the software we're going to introduce called Solid Edge. In this, you will do things like matching or generate features based on the mesh files, and you get this initial model, which you see that all the surface now is perfect. It's all pure flat. However, the angle is not good, right? So the next step is to restrict all the features with engineering intent. And this step is why reverse engineering is a little bit hard if you don't have engineering background, because you have to guess like how this model was designed initially by someone else. For example, let's say we scanned your cell phone, okay? Most cell phone today is just a box, okay? And if you scan it, the top and bottom surface, first, they are not perfectly flat. Second, the top and bottom surface may not even be parallel. However, when you were doing reverse engineering and getting the CAD file, drawing the CAD file off your cell phone, you know that the top and bottom surface of your cell phone has to be parallel, right? When someone designed it, they design it as a parallel. Otherwise, it will not be a box. And also, the for side wall will be perpendicular to your bottom surface, right? So this step, you will be restricting your model by guessing engineering intent, like guessing all the features relationships. And also, another thing is what the size of the object will be. Take the cell phone as an example again. So, you know, you have the thickness of your cell phone, right? For example, if you scan it and you measure it, it might be somewhere like 5.02 millimeter thick. However, you know, when someone was designing this phone, they don't put a number like 5.02. It's not a reasonable number. Usually when they were designing it, they will put something like 5 millimeter of thickness for this model. So when you will reconstruct this object, you have to guess what the true value is, which should be 5 millimeter in this case, okay? And this is what we have. This output for this reverse engineering process is a reverse engineering model, which also could be a CAD file or a STL file after it. And the final step will be how to use this model, which on the screen, what we do is manufacturing, but you can also do more design, like improve this design, or based on the reverse engineering model, you can do your own design. Okay, now here we have a general walkthrough of the full process. Let's see, another question is why to use scanner for reverse engineering? Because, you know, reverse engineering is actually a pretty old, or I'll say, a concept with long history. Before people have scanning, even before people have this computer, you can also do reverse engineering, right? You see something, a wood carve very beautiful, or a chair very beautiful, you can just handmade another chair out of it, do a copy of it. You can draw your blueprint by your hand with papers, and you don't really need to use scanner to measure the chair. You can use just rulers, calipers, other things to measure it. You can also do in reverse engineering. But why we want to do reverse engineering with scan data? The answer is pretty simple, because reverse engineering with scan data is supposed to help improve the efficiency and accuracy. And let's talk about this based on here we have this application case. So you see on the screen, we have a pair of glass which broken at a snap in between from the middle, okay? And this is a metal piece in between and it just cracked. Let's comparing the two ways to do it. So like I said, using scan data help you to be more efficient and be more accurate. This is because scanning is a more, the scanning process gives you more data, all right? You all know that the scan data is like a bunch of point cloud, right? So the scanner actually sampling like thousands or millions of points on the surface of the object. Comparing to, for example, if you use a caliper to measuring the part, you can only measuring a certain areas, like say you have 4 or 5 measurement. Comparing to 1,000 measurement, scanner is way more efficient than the normal measuring process. And also, because you only have limited measurement with the normal process, the data might not be accurate enough. So you may have to doing the measurement again if you don't have certain areas, or if you manufacturing a test piece and see that it's not fitting good. If you're using scan data, usually you can reduce this part and you can efficiently get the measurement of the object. Here you see that we just scan this middle part of the glasses and we reverse engineer it in solid edge. Then we reprint it with a metal printer. Then we just do some surface finish. And finally, we just repair this pair of glasses. Okay. And this is actually what reverse engineering can help us. This is one of the aspects of the application is to do repairment of something that's there's no spare parts on shelf. So you can use reverse engineering to reverse the broken part and to repair the thing. And here's another case of what reverse engineering can do is to build this, design this white body kit for the car. Okay, here we have the Mustang, and what we did is we scan the side of the car body, right? And we do reverse engineering to get the surface data. Then based on the reverse engineering the surface data, we can do more design on it to design this white body kit and finally print it out and install it on the car body. So this is another way to use the result of reverse engineering is to do more design based on it. Okay. So here, let's come back to the process of reverse engineering. Let's limit it to what's the process can be if we were using scanning data and the software we have, which is Solid Edge. And also this process also works if you were using like GeoMagick Essentials with other CAD software like SolidWorks or other CAD software. It's also the similar process. Okay, mainly the process divided into 4 parts. The first part will be preparing the raw data, in which you will be, for example, aligning the data, of course, because the scan data is floating around in the 3-dimensional space. And other things will be like you may need to fix the holes. You might need to delete whatever data you don't need, things like that. So first part will be preparing raw data. you can do it in Solid Edge, and you can also do it in Geometric Essentials, or even you can do it in our scan software. We have the movement function to help you align the data to the global coordinate systems. And also we have all the mesh repairing functions like simplifications, like mesh optimizations, things like that. Okay, first step, preparing raw data. The second part will be generate reference. Okay, based on the scan data, we have to extract reference. For example, if I scan, let's say I scan my cell phone, I need to extract the top and bottom surface, the four walls, to help me to like quickly construct the body of the cell phone, right? So the next step will be generating reference. This reference will be used in the next step, which is called design based on reference. All right. So like I said before in the beginning, my answer to what reverse engineering is that it's also a design process, but you have more reference. So now you were still doing the designing, like someone designing the cell phone. You also need to do CAD work. However, you are not doing CAD work from zero, not building something from your mind. You're actually building something based on the scan data, based on the reference you generate from the former step. And we will talk about this later in detail. And the final step for this process is to output. Like I said, you can just simply output the STL file for printing, or you can output the a draft for like machining, manufacturing, or like all the other traditional manufacturing process, or you can just, based on this CAD file, you can do more like designing on it, like what they did for the white body kit. All right. So yes, this is the fourth step we're gonna cover for reverse engineering, and let's go to the next part, is how to do it with Solid Edge. Okay. So we're gonna go through the full process step by step. And the first thing we're gonna take a look is how to prepare raw data, all right, in Solid Edge. Here's something you can do in Solid Edge for this step. Of course, part of it, like I said, you can do it in the scan software. But generally, there are three things you can do in Solid Edge if you want to prepare raw data. One is called fixed mesh. So you have to repair your mesh, fitting all the holes, patch all the holes, delete the data you don't need. You can align the data to the world coordinate system. You can clean up the mesh. And let's take a look of the software interface. So the first thing we want to do is we want to open a STL file, which is the raw scan data. And make sure when you open it, you start it with a part. Whatever standard based on your selection, but make sure you start it as a part. If you do it as assembly or other things, you will not be able to access the reverse engineering tab, okay? So do it as a part. Select this one. Then the STL file will be opened and a new part will be generated. And you will be able to see it on your screen. Notice that not all the scan data will be shown in the first place if you open it up. Sometimes it may look like this, so nothing on your screen. One thing you can do to locate your scanned data is you see on the bottom right, here we have this block to change your view, and next to it is a small home button. If you click on it, it will go back to where the scan data is to help you locate the scan data, all right? So if you cannot find your data after import, click this one, home button. And here we have our scan data. And let's take a look at the clean out prepared data functions. Mainly, it will be this area here, clean up on the top, clean up a mesh, a line, or part. And the first thing I recommend to do is to run this geometry inspector. Just click on Go to check the model. It will tell you if there's any faults or anything wrong with the mesh data. Most of the time, it should be okay, but sometimes there are small faults in the scan data. You might need to click on Heal Body Faults to heal your model. But for our case, this model is pretty fine, so you don't really need to do it. So the first thing I recommend you to do is doing this geometry inspector to heal your model. All right. And next thing, there are some other functions what we have here. For example, we have delete mesh. So you can select certain area to delete if you don't need. Here I have another model which I think probably need more cleanup. Let's do geometry inspector for this model. You see there are like 13 faults found. So just click on Heal Body Faults. Sometimes it might take like a few iterations. So Heal Body Faults once might not be able to give you a good result. So it might still tell you that there are some faults. You might need to click it again, but we are lucky this time. There's no faults found with the specified model, so it's good enough. Just click on Close. All right. And the next thing is we will be deleting the data we don't need. For example, we have this fan blade, and what we want is, what we don't need is the bottom part here. So we can click on Delete Mesh. Solid Edge provides you a couple of different selection tools here. If you click on the toolbar here and click on the drop-down arrow, you will see that you can select the whole body or surface, or the default will be the brushing tool. So like this, you can paint on top of the scan data surface to select certain area. Or we have this fence function. So it's mainly like drawing a box. Like this, so that you can select a large part of the data at once. And you can click on the check mark or right click or hit enter to confirm. And you see that the data will be deleted. And next we have the smooth mesh function. And also you can use different select tools. You can just doing smooth for part of the data, or you can smooth the whole thing. For example, you can use brush tools to just smooth a certain area. Like this. Or you can actually, if you choose this body surface and you click it, you will be selecting the whole thing. And if you smooth the whole part, it might take a little bit longer. Okay, so this is smooth mesh function. And next one, hole filling. It's actually similar to the scan software. So you select body and all the holes will be highlighted like this. And what you did is you just select the holes by clicking on the edge perimeter and you choose your strategies. Tangent should be good. You check, it will help you to fill the hole. And of course, we have this remesh function. This works more like the simplification function in Solid Edge, not in Solid, in our scan software. However, it does both ways. So you can simplify this model, or you can actually make it more complicated. So it's not one way, you can do it two-way, all right? You can either simplify it or you can make it more complicated. And the next thing I want to talk about is this align data functions. Generally speaking, I'll say that if you were doing alignment in Solid Edge, it's not that accurate, I'll say, because you don't have much control of the alignment result. Not like what we have in the scan software or in like other software like Geometric Essentials. You have much more control of the aligned data result. Here, but the good side is that if you're using Solid Edge to do alignment, if the object itself is pretty simple, you may do it more easily. For example, what I have here is like a pure, generally a box-like shape object. And this kind of object, I recommend you to use align function in Solid Edge to do it. Like if you click on align, the first thing will be, it will ask you to select the object you want to align. Or you can take a look at the prompt bar on the bottom. It will tell you what you have to do currently is to select the object. Okay, so you click on the mesh and you right click or click on the check mark to confirm. Then the next step is to select the way you want to align the data. That's hard to align. The smooth function, actually, there's some control. You can select how much iteration to do the smooth. The more you do it, of course, you lost more details. And I think it is easier. It's actually easier to align the data in Solid Edge, but it's more accurate in the scan software. But we are actually trying to develop more alignment function in our scan software to make alignment easier, okay? So we're probably gonna come up with more alignment functions in the future. Okay, let's go back to Solid Edge. So now what we have to do is to select, let me close this. Is to select the way we want to do the alignment. This is how you construct the new coordinate system. So basically, the alignment is just by construct a new coordinate system on your model, then align this coordinate system to the world coordinate system. So SolidEdge providing 4 ways to do it. The first one is use principal axis. So it will construct the coordinate system inside of the, I think it's like the geometry center of your scan data, like this. You can see that a new coordinate system has already been constructed. And if you use it, the data will be aligned based on this coordinate system. And another way is to use the best fit bounding box. So if you choose this, the software will generate a bounding box based on your scan data. So it will try to make a best fit bounding box, which is supposed to be the smallest bounding box of this data. If your scan data is square enough, the second one will give you a really good readout. However, for most of the cases, for example, in our case, you see that the bounding box is not so perfect. All right, it's still a little bit inclined. And when you use the second way, the bounding box, you can lay down the new coordinate system at the end of each edge, or the middle of the edge, or you can put it in the middle of any surface, like this. So in this way, you can put it on like one of the corner of your scan data. And the rest two, one is called customized bounding box. This one is actually involving region identification, and also the use geometry reference also will be working with region identification, which we will cover in the next step. So we will talk about this later, these two later. So first, let's try just simply use the principal axis. Right-click to confirm. Then the next step will be select the coordinate system you want to align to. And in our case, we want to align it to the world coordinate system. So click on this base system, and you see that data will be aligned to it. Just click finish. Okay, this is how the alignment works in SolidEdge. Like I said, it's way more simple if you're comparing to the 3-2-1 movement in the scan software. However, it's not that accurate, I would say. And finally, we have this show faces edge. This one is actually, I heard somebody ask for this in the scan software. It helps you to see the edge of each triangle of your mesh data, and help you to see how fine your scan data is to judge if you need to remesh it or not. Okay, so it's kind of like a switch to turn on or turn off the faces edge display. Okay, so this is the first step we want to do if you do reverse engineering. Let's go back to the slide. So basically what you do is you fix the mesh with the geometry inspector. You go align the data and you clean up your mesh. How do I know when to remesh? When the triangle is too small, yes, because I haven't mentioned one thing is that when you're using SolidEdge and when you're importing the scan data, make sure it's not too large. if it's something like 100 megabits, it's okay to import, but when you were doing the mesh related operations, it might take a long time. So in that case, I recommend you to remesh first to make the triangle smaller, to make all the faces larger actually, to make all the faces larger and to make the file size smaller so that it's easier for SolidEdge to do the future operations. The remesh function, it actually was based on the curvature of the surface. So it will try to follow the curvature, so it will not lose any of the detail of the data. So if you use remesh function, don't worry that the detail will be lost. There's actually not much rules for accuracy and workpiece tolerance. This one, I recommend you to do some more tests because I don't really have like a relationship between the accuracy and the tolerance. Okay, so this is first step, preparing for the raw data. And the next step we want to talk will be generate reference. And here's what we want to do to generate reference in the scan data. Mainly, there are two things we can do with SolidEdge. One is by fitting features, and the other one is by section sketch. Okay, let's go back to our software. We go from one, we're gonna walk through both of them. And the first thing is to extract surfaces, extract features. And there are two things we need to do if you wanna extract surfaces. The first thing, you wanna identify the regions, all right? First step. And the software give you two ways to do it. One is to do it automatically. So for example, if you have a data which is like a machine data and all the surfaces are more like regulated, you can use automatic region creation. Basically, you click on it and click on the object. It will try to calculate and generate the region based on the surface curvature. It will try to identify different features. This actually is a quite slow process for SolidEdge because it's mesh related. And you'll see that different regions, or at least I'll say different kind of features were divided into different regions. Let me just right click to confirm. So you can see that the yellow area is what SolidEdge thinking it might be a plane surface. Yes, you will access to record video. And this blue area will be the cylinder, the corn, and we also have cylinder been detected. And this region can be used to construct surface in the future. And of course, you see that some of the area was not well detected. For example, here, because it's too small, it didn't detect the plane surface. A way to do it is that you can manually define the surface using like the brush tool. So you can manually brush the area to divide it. And just right click to confirm. And after you divide the regions, the next step is to extract all the features. You can click on extract and do the extract all. So it will do everything for you automatically. It probably took some time. And the other way is also to do it manually is you can click on the fit. Let me see if I can stop it. All right, let's try to calculate all the surface. When you manually select the surface color was blue as cylinder, but it was a plane. Yes, when you manually doing it, it's always in the same color. However, it's actually fine. It doesn't really matter because this color only affects the extract functions. So if you were not doing all the extraction automatically, the color doesn't really matters. And also you can actually manually pick your colors. For example, if you really need the yellow color, you can also change it back to yellow. This is what you can do. All right. And okay, go back to what we were left is that we have this menu fitting functions. And if you click on fitting, you will see that here are certain different feature you can fit. The Solid Edge provide plane, cylinder, sphere, cone, and this BSP line is actually beta special line. It's actually a free surfaces. Okay, and let's take this box for example. We can fit the top and bottom planes like this. So when you're doing fitting, you just select the area you want to select the part of the reference data you want to fit, and putting a tolerance. Actually, you can put a large tolerance because the fitting will not be that hard. But if you put a small tolerance, it may give you a fail warning. So usually I will leave this tolerance to the default. But if you are not satisfied with your fitting function, you can try to play with the tolerance. Try a smaller tolerance, see if it gives you a better results. But most of the time, if you are not satisfied with your fitting data, I recommend you to check your region. So the fitting region, see if you have enough data to fit your feature. Okay, and let's do it to all other 4 wall. You can just right click to confirm, which is pretty quick. And the top surface. Okay, like this. So this is option number 1, is that you can actually use identify regions, divide regions, and then just extract surfaces or other features out of it. And option number 2, constrain them. Not possible to you are not able to constrain the surfaces by fitting. However, you can constrain them after you fit them, and we will talk about it later. The other way, go back to where we left. The other way is to do section sketch. Like this. What it does is that it will make a plane or several planes. For example, here we can select the object we want to cut. Then we select the plane, tool plane to cut the scan data. And you can select number of offset planes here. For example, we do only 1. And you can click on the arrow to choose the direction. And you can set the offset here, 5 millimeter. You'll be able to see the preview on the software. So it's cutting the top 2 cylinders pretty well. And you click on OK. And if you turn off other features, you will be able to see that it's actually, what it does is that it uses a plane to cut the scan data, and it will generate a sketch based on the intersection of the plane and the scan data. And like I said, you can do multiple cross-section cutting. However, it's only planar section sketch, while I think in Geometric Essentials, 3D System provide more different section cutting functions. Like they can do plane around a certain axle. So it's more useful if you were doing something like a cylinder shape. In Essentials, in Solid Edge, it's only like planar cutting, okay? And this sketch can be used for future design too. Okay, so this is the feature, the reference generating part. Basically, what you do is 2 things. Either you just fitting features directly, or you can use section sketch to make some cutting sketch. And like I said, the feature you fitted, it's not perfectly parallel or whatever. There's no restriction to the direction or to the shape. It's purely based on the scan data and based on the area you selected. However, it doesn't mean there's nothing you can do. In the future, you can still restrict them because it's a CAD software, so there's always a way to restrict your surfaces. Okay, so let's go to the next step, which is design based on the reference. This is actually the, I won't say most complicated, but also a large step which we're gonna go through. So in this step, you are actually doing design based on the reference you generate in the last step. For example, you're gonna combine the surfaces to a solid body, and you can generate more features with the sketch you made directly, or you can do direct meshing editing, and there's no need for generating reference if you do mesh editing directly. I'll show you how to do this. This is actually a new feature in Solid Edge 2020. Okay, let's back to screen share. Here we already have the 6 surfaces for this body part. The first thing you want to do is, if you want to use all the surface to generate a solid body, you have to make sure all the surfaces are combined together to a fully enclosed body area. So take our data as an example. It's actually some holes here and there. It's not fully enclosed. So what you want to do is you want to extend the surfaces to make sure they intersect with each other. What you do is you click on the edge of the surface you want to extend, right click to accept, and move your cursor a little bit to where it can actually intersect with other surfaces. Left click, settle down, then right click to confirm. Just doing this left click and right click a couple times so that all the surfaces are intersect with each other. I know this might be a little bit complicated. I think the ideal way is that the software can try to imagine all the surfaces are extended, then try to calculate by itself. But currently, you have to do it manually like this. Okay, it looks like fine. And let's see if it's good enough. So once you think all the surfaces are intersect with each other, next thing is to generate the full body. What we're gonna use is this intersect function here on the top. Click on it. And on the toolbar, we wanna select this create design body. Then you just select all the surface you have here and right click. And you see that the software will try to detect if there's any enclosed region inside all the surface you selected. If there is, you will see it here. A couple things you can do. First, you can, if you have multiple regions, for example, if I have another plane in the middle cutting the region into 2 areas, you will see region 1 and region 2. And here you can check unite regions to combine them together. And since we only have 1, you don't need to do so. And also you can check this consume surfaces. This means after you construct the solid body, it will delete the region, it will delete all the surfaces that was used to construct this body. In our case, it's all like the 6 surfaces that we have before. It will all be deleted. So usually I check this because there's no use for these surfaces anymore. But if you still need to use the surfaces, you can uncheck it. All the surface will be remain there. And you just, after you make sure it's, you have the enclosed region you have, you just click on close and click on check mark. And you see that on the screen, we have this box, which is in gray color. Remember that before the surfaces is in purple color because it's not a solid body. And in solid edge, all the solid body will be displayed in this gray color. Okay, so this is our base feature. Like I said before, there's no restriction for the base feature. So once you have the base feature done, next thing you want to do is to relate it. So first, go back to the Home tab on the top. And here we have all the face relation you can set up. First, of course, you will be setting a rigid base, which I think should be the bottom of this object. Then we can make the top one here parallel to the bottom surface. And we can make all the side walls to be perpendicular to the bottom surface. So choose perpendicular and choose the 4 sides. Right click to confirm. Then you choose the bottom, which is the element to position the selection. And you see all the 4 sides are now perfectly perpendicular to the bottom surface. You can do the similar things. You can make the both side wall perpendicular to each other, things like that. So this step is where you putting all the generate all the relations like this. And also, based on the basic features, you can also decide the dimensions of it. For example, now the Foley length is around 200.34, and like I said before, it should be a reasonable number, so it should be 200. And also the width, like it's 99.58, you know it should be 100. So this is what I said. You have to restrict your models later after you construct the body, okay? So this is the one way to do your design is simply for some of the simple features, you can just fitting features and combine all the surfaces. You fit it to a solid body, then just create the model you want. And there's another way to do so is that using the sketch that we constructed before. For example, now I want to construct these 2 cylinders I have here on top of the surface, these 2. What we can do is we can use the sketch we have before. I don't recommend you to use this sketch directly, but I recommend you to use them as a reference to locate your object. For example, we can do circle, and let's do the sketch on the top surface. And you can do like 3-point circle. To draw the circle, like this, and we can do the same thing to the other side. You can use Control H or here, Sketch View, to go back to Sketch View button, to go back to the Sketch View. For example, if you are in somewhere else, if you click on Sketch View or hit on Control H, it will go to the Sketch View to help you better doing the sketch. And let's make the circle again by 3-point. You can select 3-point on the sketch you have here. All right. So now we have a basic sketch. Next thing we want to do is we want to dimension them, okay? To make sure it has a reasonable size. So this one should be 10 for diameter. Same thing here. Should be 10, okay? And also we have to make sure it has a good location. So should be 20 from one side. We have the relationship. Actually, it was made based on the circle that we had before, generated from the section sketch. So we have to detach the relation. It was set to be on the same circle. So I select it and delete it. Oh, too much. Tangent. Okay. Now you can change it to 20. And same thing, the distance to the other side should also be 20. And for time reason, I won't do to the other circle, but you know, it should be the same thing. You have to define define its location to make sure it's a reasonable number. And you can select both region, and let's bring up the scan data, and click on the arrow to draw the object. And of course, the height need to be also a reasonable number. So I think it's around 15, so it should be 15. Let's see if it looks good. Like this. So this is how you construct features based on the section sketch you have, or you can actually draw the sketch by yourself based on the scan data. It's also workable. For example, for the hole here, you can actually just draw a box based on this area. It also works. And this is the method number 2 I was talking about. is to generate features based on Sketch. Of course, you can combine both. There's a lot of different ways. I'm just introducing the tools. However, there's a lot of different ways to do so. For example, let's take this blade as an example. If you want to draw one of the blade here, a good way to do it is that you can manually divide the region for the top and bottom surface. For like a free surface like this, I recommend you to select as much data as you can to get a better fitting result. You might notice that you cannot change the size of your brush. However, you can change the size of the model. So if you zoom in, the brush is actually relatively smaller. So that helps you to select more areas. Like this. And we do the same thing for the bottom. Where are we? We do the same thing to the other blade, other side of the blade, to paint it. I might be a professional artist after this. Feel like I've been painted a lot. Okay, like I said before, try to get as much data as you can so that you can get a better fitting. Okay, so you have the both side of the surface region divided. And next you want to fit free surface. And what you want to choose is this beta special line, BSB line. Select the region and right click to fit. Oops. And do the same thing for the top. Now remember, I said you can combine both way I just said together to construct the model. What I mean is like this. Actually, after the top and bottom surface generated, next thing we can do is we can draw the outer shape of the blade. We might need another surface. Let's generate the base plane. Let me manually paint it some area. So basically, we just select some area on the bottom surface and try to construct the base plane. And actually, the sketch should be down on the base plane. Let's do it again. Lock to the plane. Outer shape. 2 lines. Here we go. So this should be the right way. So select this region. This is the shape of the blade from the top view. And you can just extrude, construct the full blade part like this. So step 1, just make the general shape of the blade. And step number 2 is, we already have the top and bottom surface been generated. We can go back to reverse engineering and use one of the useful function called replace face to replace the top and bottom surface. So like this. Select the top surface and right click, replaced by the fitted top surface. And do it to the bottom too. Replace the surface. And here you can see this how you make the blade in an easy way by combining both fitting surfaces for part of the surface where it's hard to draw, and also you can use directly section or directly modeling based on the scan data reference to generate something so complicated like this blade. Okay. So let's go back to the presentation. Now, we already covered 2 parts, combine surfaces to solid bodies and generate feature with sketch directly. And also another thing is combine both of them. So you use the surface and the sketch to generate some of the features, like what you did for the blade. The next thing will be direct mesh editing. This one, like I put on the slides, says that no need for reference. So actually, you can do it without the last part, without generating any reference. You can directly manage, directly changing your scan data. However, there are some constraints here. So let's go back to our object first. Let me import it again. So now we have this clean data. Like I said before, there are constraints about it. And the first one is that it has to be a fully enclosed model. So if you open it, you need to see that it's called surface mesh body here. On contrary, I think it's not fully enclosed. Otherwise, you can actually turn it into a solid body. Let's see, fill holes. There are still some small holes, not not filled. And let's see if any small entities. Seems there's no more holes, so we can check if we can turn it into a solid body. Yes. So once the body is fully enclosed, you should be able to change it to a design body like this. So making it into gray. Remember that unless the body is fully enclosed, otherwise you will not be able to do this step. All right. Then in this case, you can actually directly doing some of the features or generating features directly with Mesh. And here's why I'm saying so. Let's generate the base surface first. And let's feed a plane, the bottom plane. Okay. Now let's say the scan data is actually looks pretty well on this model, but sometimes the hole may not be scanned perfectly, because some of the deep holes cannot be scanned by the scan software well. So usually you probably have a hole like half closed or not perfectly rounded. And let's say some of the time you only need to you need exactly good location or a good feature only for the host for the fitting reasons, or for the let's say if you want to put some things together, you only need the hole to be perfectly rounded, while the other area you can let them remain how the scan data shape, so which are you don't need much information from the surface, so you can only editing the whole area like this. Basically, you can go back to sketch, and you can just do sketch on the plane, bottom plane. You generate it. Let's go to 3-point. And we can do this a little bit larger so that you can see the difference. So take this as example. So I have a sketch here. Let's select the region. And you can drag the handle. And here on the toolbar, since we want a cutting material, you can select cut. Or you can actually hitting on the space bar to shift from cutting material to add material, or the other way. And you can tap, you see on the bottom, it says you can tap shift to toggle symmetry or not. And you can hit on spacebar to change between adding or cutting material. And now you see like I can use the sketch to directly cutting the mesh object so that it will give you a pure rounded hole. This works, for example, if the hole was not scanned perfectly, or if this the only mattering feature on the device. So for example, if I only need to print out a part like this to replicate it, I can generally do a scanning. And if I want to install it on something else, I just recut the holes for the other screws, and we can just 3D print this model out. You don't really need to go through the full reverse engineering step if you don't need a CAD file for your output. So I recommend you use this function unless you only need to do 3D printing, or I'll say if you only need pure mesh data for your output. But if you are using, what you need is the CAD model, I'll say you have to go through the full reverse engineering process. Okay, so this is step 3, design based on reference. We already shared a lot of different ways to do it. And the last one would be to prepare your data. Will be output, sorry. Will be output your data. And we already talked about this a lot in the beginning. You can use the data to do 3D printing, do machining, or you can do more design works. Like what we did here is that before we scan the human face and we constructed a printed mask set perfectly fitting your face. And this is what we have today for reverse engineering. We go through the full process from prepared data to generate reference, to design based on reference. Then we have a final output.